All right, and continuing the podcast on the strength of acids, we're going to talk about the strength of oxyacids. An oxyacid is going to be an acid that's got a hydrogen, an oxygen, and one other element. So it always has a polyatomic. We're going to talk about these in two different chunks. So basically, there are the types of acids that have just one oxygen. And then your, well, it's not your central atom, but your other atom that is attached to the H and the O. And then you have the other possibility, which is you have more than one oxygen. So we're going to talk about the ones that have one oxygen and the ones that have more than one oxygen separately. Okay, so let's talk about the ones that only have one oxygen. Okay, so if we are looking at these right here, okay, hopefully you see that Cl is definitely the strongest, where I is definitely the weakest. Okay, so basically what's that is telling us is we know that chlorine is more electronegative than iodine, so it's pulling the electrons towards the oxygen and towards itself, which is weakening this OH bond, giving you some partial negative, partial positive charges, and so the hydrogen just falls off really quick. So the more electronegative X is, the stronger your acid's going to be. Okay, so as electronegativity of X increased, going from I to Br to Cl, we saw that the strength and the Ka also increased. All right, so some examples. So we have our H2SO4 and our H2SeO4. So I want you to notice that the only thing different about these is the S, E, and the S. Okay, so they have the same number of oxygens and the same number of hydrogens. Okay, so the only thing that's changed is that X element, the other element. Okay, so I just want you to keep that in mind, because when we're comparing those two, that's when we're looking at electronegativity of that different element. So S is definitely more electronegative. Because S is more electronegative, that means H2SO4 is going to be the stronger acid. All right, now let's look at the other possibilities for oxyacids. So now instead of talking about changing the X atom, let's talk about changing the number of oxygens that are attached to that X atom. So as you can see, moving down the chart, the Ka value is getting much bigger. So basically what that tells us is that the more oxygens we have, the stronger the acid. Oxygen's a pretty electronegative element, so what it does is it pulls the electrons towards this whole deal, okay, and it's weakening this bond here, and because that bond is very weak, this comes off really easily, which is the definition of a strong acid. So the more oxygens, the stronger the acid. Okay, so here's another little depiction, but as I said, the more oxygens, stronger the acid, bigger the Ka. All right, so some examples. Okay, so we have HNO3 and HNO2. We want to discuss why HNO3 is a stronger acid than HNO2. Well, duh, it's got an extra oxygen. The more oxygens it has, the more it is pulling the electrons further and further and further from that hydrogen, making that hydrogen pop off really easy. All right, let's look at some other examples. So here we have amino acid alanine. It has 4 different types of hydrogen atoms. So here's your 4 types. Okay, they're kind of like on each side here. We want to pick the hydrogen that is the most acidic. Okay, so look in here. We definitely have C's and N's, right? And then we just have a little regular hydrogen. And then we have a hydrogen that is attached to 2 oxygens. Okay, so hopefully you went straight for this right here. This is going to be the most acidic. It's got those 2 oxygens. Oxygen's very electronegative, so it's definitely going to be the COOH, that hydrogen. All right, some biological examples. So we are given a diagram of a molecule, and some different H's on the molecule are labeled. We're given the pKa for hydrogens A, B, and C, and then ask which one is the most acidic. Okay, so you've kept, basically, if you look here, hopefully you notice that all of these hydrogens are all considered C hydrogens because they're just attached to a carbon atom. And then you have B. B is attached to an oxygen that is attached to a carbon. And then here we have hydrogen that's attached to an oxygen. Oxygen is attached to a carbon, which is double bonded to an oxygen. Okay, so looking at the pKa values, hopefully you remembered that the smaller or more negative the Ka is, the higher, the pKa is, the higher the Ka is. Okay, so because A has this very low pKa, means it has a high Ka. High Kas are going to be your strong acids. So it's definitely this hydrogen here. And the reason it is because these oxygens are contributing to one another and pulling all the electrons that direction away from the hydrogen. All right, and last example, another biological molecule. Okay, and it wants us again to determine which of the hydrogens is most acidic. Okay, so basically what we have is we have these hydrogens, which are C. They're all attached just to a carbon on the chain. And then we have B, which is attached to an oxygen, which is attached to a carbon. And then here we have a hydrogen that's attached to a N+. Okay, so basically we can start process eliminating, right? We know it's not going to be those right there. All right, so now we got to determine between these two, right? Okay, so let's talk about this. Okay, so oxygen is definitely pretty electronegative, which means it is, pulling electrons away from the H, right? Okay, N is also pretty electronegative, not quite as electronegative as oxygen, but it does have that positive sign there. Remember, that positive sign means it really, really wants to donate those hydrogens. So this hydrogen's definitely just going to pop off really easy. So this is definitely the most acidic hydrogen on the molecule.